Hi everyone, welcome to a super fast demo of the law of cosines. This is meant to be a refresher to those of you who have seen this for the last year or two. If you're sitting in Algebra 2 right now, you have seen it both in Geometry and Algebra 1, so it's meant to be a very, very quick refresher. Okay, if you need a more thorough explanation, I do have other videos posted that are a little bit lengthier, that go a little more in depth, but this is just supposed to remind you of how this works. So, again, we're talking law of cosines here. And before we get started, I guess we should get the formula down. So this is what I use as the formula for law of cosines. I'll explain why I'm saying it that way in just a second. Okay, if you look in a textbook, you would find that there's actually multiple versions of this formula, okay, with different letters kind of hanging out here out front. And if you read the textbook explanations, they're going to talk about how you have to pick the right formula for the right situation. You have to know if it's A, B, or C that's missing. I think that's a mess, okay? So I always just use this version of the formula, and that way you only have one formula to memorize. And then I just know that whatever it is that I'm solving for, I'm going to label A. So if it's a missing side, I'm going to label it with a lowercase a. If it's a missing angle, I'm going to label it with uppercase A, and everything else will fall into place from there. Okay, so let me throw down an example here. So in this example, and first of all, I want to point out this is not a right triangle. Okay, when we were doing SOHCAHTOA, you had to work with right triangles. This will work with any triangle. But you'll see that I've got two side lengths and an angle measure, and I'm looking for this third side length. Okay? If this was a right triangle, we could use some SOHCAHTOA, but we can't. So, again, what I always do is say to myself, what is it that I'm trying to find? I'm trying to find a side length. So instead of x, I'm going to rename this a, and lowercase a because it's a side length. And then the angle that's across from it, that's going to become angle A. And then the other two sides are just B and C, and it doesn't matter which is which. Okay, so that's B, that's C. And then I'm just going to throw everything into the formula. Okay, so that's going to look something like A squared equals 4 squared plus 6 squared minus 2 times 4 times 6 times cosine of 24. And although that looks really complicated, you'll notice that all of this is just numbers, okay? Which means all of this can go into your calculator in one shot. So let me do that quickly. So typing that straight into my calculator, I get 8.15 essentially. And just remember that that's really A squared, okay? So what I need to do with it from there is take a square root on both sides. And let's see, square root of that number comes out to be 2.85. Okay. Now, I actually did a little double take here too. My picture is not drawn very well. So, although you may be looking at this and going, how could this side possibly be 2.85? This being a 24-degree angle, I kind of just made that number up. That's clearly not a 24-degree angle. That's probably closer to like a 45-degree angle. So this side, if this was truly 24 degrees, this side would be much, much shorter. So 2.85 is actually reasonable for that. So sorry about my bad drawing skills, my bad labeling skills, but mathematically, I promise you I know what I'm doing. Okay, now I'm going to do a quick one on how to work with it when this A is what's missing, and that does get a little more complicated. Okay, so here's another example, and you'll notice that up at the top we've got that formula for law of cosines again. And this time my triangle has all three side lengths labeled, but I want to find an angle measure. So let's say I'm trying to find this angle measure right here. Okay? So, just like before, I'm going to take that thing that I'm trying to find and label it A, but this time because it's an angle, I want to label it with a capital A. But then, if that's angle A, then directly across from that should be side A. and then this is B, and this is C. Actually, it doesn't matter which is B and which is C. Okay, could be either one. So now, I'm going to fill all those pieces in. This time, though, I do have a number to put out front there, so I'm going to say 9 squared equals 15 squared plus 7 squared minus 2 times 15 times 7 times cosine A. Okay, and I know it's tempting, just like we did before, to start plugging all of this into your calculator, but you can't, because all of this is attached to that cosine A. Okay, and so you can't combine these with these. They're not like terms. It would be like combining, 5 plus 7 plus 2x. You can't combine the thing with the x on it. Okay, so these numbers are going to have to stay separate, and what I'm going to have to do is move them over to the other side to get this by itself. So what I can start with, this is all numbers here, so I can do 15 squared plus 7 squared, and I can go ahead and do 9 squared. So see those 3 sections that I just sort of underlined? Here, here, and here? Those are kind of the chunks that you would start this with. Okay, so 9 squared is 81. 15 squared plus plus 7 squared is 274. Minus, and then let's see, that's 30 times 7. So that's 210 cosine A. Now, I have a lot of people who listen to my advice and don't combine all the numbers back here, but then they get to this step and they still go ahead and subtract those two things. This 210 is still attached to a variable, so you cannot put these two things together. It's like there is a wall right here all the way through your problem. Okay? What I can come along and do, though, is subtract 274 from each side. So here I get negative 193 equals, don't lose track of that negative sign, so there's negative 210 cosine A Okay, just shrink everything so that everything would fit here. Now I'm going to come along and I'm going to divide by this negative 210. And that does give me a decimal. That's okay. I get 0.9190 equals cosine A. That's not your answer yet, though. I do have some people who get to this stage and they kind of freak out thinking that this is supposed to be their answer, and they know that's not right, which is good. This represents the cosine of A. It doesn't represent angle A. And if you watched my other video, I mentioned that anytime you're looking for an angle measure, you're going to end up using an inverse trig function. So from here, I am going to do the inverse cosine of that decimal. And looks like 156.8. And looking at my triangle, that probably makes sense. Okay, so by far, this is the one type of problem that probably takes the most steps. All the other ones you can do in just a couple of steps. This one, you really cannot avoid putting this much work into it. Okay, there's really not a shortcut. I promise you I would teach it to you if there were. Okay? Okay, that's it for law of cosines.